So I'll share my screen. Okay, so in terms of the OLAP quiz, all right, what topics or entities or fact tables generally about? I think a lot of you all got this right. You said like transactions or events. Events is probably a bit more accurate, which a lot of you said. So for example, right, we can think of, the context can be different, but you can think of like an orders, if this is e-commerce, right? You can think of like clicks, right? Like website clicks, if maybe we're doing digital marketing, something like that. Other things like tickets, right? If we want to go to like our airplanes or our movies, right? So like this is like kind of the main coming together. Like if you think about maybe why that is, well, like if you go to orders for tickets, like this is where kind of everything comes together. Like the ticket is like I watch a movie at this time in this location, right? And when I reserve the ticket, that's what I'm reserving, right? So it deals with kind of like multiple different entities. What types of topics are generally reserved for dimension tables? They say like this is context about the event, right? You could also say like attributes, I guess, typically we said like the who, what, where, when, right? Those types of things. So just the 4 Y's or 4 W's, right? Everything but Y. In terms of data types, I think everyone basically got this right. How do fact tables and dimension tables differ? So our fact tables are generally numeric, right? Meaning they consist of either foreign keys or what I would call like a target, a target that we wish to optimize for. So target is like it's a data science term. It's, if you want to sell, it's what is your goal essentially, right? So if your goal is profit, right, your target is going to be profit. If your goal is simply visitors or clicks, right, then that's kind of the number that maybe you want to optimize for. But generally, it's a bunch of like foreign keys and then the target. Whereas the dimension tables, right, these are generally more like attributes in text, right? Lots of times it's text, the person's name, the city, things like that. OLTP tables generally have fewer columns, right? We generally break our tables up into, if we have our data, we'll break it up into a lot of small tables, typically, right? OLAP database, we have fewer tables, but they're bigger. Each one has more columns. Okay, the reasons for structuring it differently. Okay, so I think there's like 2 reasons that you can think about. One is like speed, and then 2 is the end user. Okay, so in terms of speed, right, with OLTP, we're optimizing. And by the way, I'd say I generally saw people get like one of these, but not mention both, is what I'd say. All right. Normally, you all mention this one, not this one. Okay, so OLTP, we're optimizing for transactions, right? This is consumer kind of facing. The consumers are like user facing. The users are interacting with our websites. We're gonna have a lot of users ideally. And so like they're clicking on a bunch of things and we're, maybe they're posting tweets or whatever. We need to be able to write them to the database quickly to have essentially like, you can think of a high throughput, right? So that I can click and then someone else can be the next person who clicks on something. And we're able to write that to the database. And then when the next click comes in, we can also write that to the database. So OLTP is generally optimizing for transactions, meaning like modifications to our data. OLAP, right? Optimizing for queries. So if we're optimizing for transactions, what that means is, well, smaller tables are better, right? Because we can write a small row at a time. If we're optimizing for queries, we no longer really have to care about that, about writing lots of data. That can happen in batches, it can happen overnight, things like that. What we do care about, however, are like joins. And if our data is more, in a smaller number of tables, then it's fewer joins, right, in performing queries, because each table has more columns on average. Okay, then you can think about like the end user. Well, with OLAP, right? The OLAP, the end user can be more, non-technical, like analysts, right? Meaning that performing lots of joins and having a very complicated, data table structure, can make it harder for them to do their jobs. So having a simpler data structure and data across fewer tables makes it easier for analysts, right? That's kind of like our data mart, whatever. And then for OLTP, right, these are more, this powers our web application. So these are technical users. And then, of course, maybe the other thing is we care about having a database of record. So that's where, we want our OLTP to have a single source of truth, which leads to kind of the smaller tables, more of them. Okay. Questions about this one? All right, what does it mean for a data to be in normal form? I'd say there's like two ways you can go with this. One is you can essentially say like single source of truth, meaning that our information is only stored in one location, right? Or you can even say like stored once across our database. And you could probably even like include stored once across the database, and I would say including any, meaning that our information, including any derived information, right? So right now I'm thinking about like the way we store a date time in an OLAP, right? That's violating normal form because we have like the day, the week, the month, and the date time, right? All that's derived from the date time. The other way, so single source of truth is like one way you could go. The other way is every non-key attribute is about the key, the whole key and nothing but the key. And these lead to the same result. All right. Like we're not going to have, we have an orders table, and then we have, here's my order, and we like purchase, and we have an ID of 1, and we say, okay, we purchase, like a boat. Let's do the columns. So we'll have the ID, we have the product ID, and then we have like the customer ID, and then we have the name, the customer name, right? Of course, now we violated it, right? I mean, one, for both reasons probably, because one, we probably have a customer's table, and so this information is duplicated, violating our single source of truth. The other thing is that this is not about the key and nothing about the key, right? It's also about the customer. So it's not just about the order, but it also describes this. All right. One thing I'd say in general is like, explain this stuff so that it makes sense. Like like the minute you kind of use any like vague kind of jargon, I don't want to like know that like someone like me or hiring, like I've spoken to lots and lots of hiring managers after like students like mine go on interviews, and they are very suspicious of hearing jargon words. Okay. Like very suspicious of it. That's like pretty typical feedback that I get. Oh, they like said this kind of fancy word, and they don't like hearing it because it means that it's going to be hard. It means that it gives them like, oh wait, it's going to be hard for me to really know what somebody knows and what they don't know if they're trying to hide that from me, right? They want you to explain it as if you know it. And you could say, okay, I'm not quite sure. This is the way I think about it, right? And then you can have like a real conversation. But imagine if like a product manager like asks you a question and you're not quite sure and you try to hide it with like jargon, that's kind of frustrating, right? Because it's like, well, how do I? It makes it feel, if they try to dig deeper, it probably feels like they're trying to put you on the spot, right? Which they're not trying to do. They just want to know the answer, right? They would just want to figure it out. Yeah, Bryn?
Yeah, so is it odd to talk about third normal form in terms of database tables, or is it really just referring to the database itself, or can it, because OLAP tables essentially follow third normal form?
No, they don't. Well, okay, so OLTP tables, right? This is our transactional database. So when we have something like, for instance, in an OLAP, right? This is where we may have, like I think I gave the example. We have a store, and maybe you have the location. That's fine. But then you also have like the manager first name, right, and the manager. Right, so in OLAP, in order to like keep this on the same table and prevent me having to do a join just to figure out who runs the store, you may violate. This is a violating norm. Like, this is not normalized, right? This is violating third normal form. Okay, so this is in our analytical database. We may collapse or relax our normalization requirements.
So it's not, it can't, it's not referring to like non-repetition in general, or like a single source of truth within the table. It's just referring to like the database.
Well, this is how we structure the table. You know what I mean? Like, this is about the tables, right? How we structure the tables.
Okay.
Right? Like, one thing I would say, I guess one kind of thing I'm starting to distinguish is, okay, well, there's how we structure the tables. Just kind of like in an OLAP versus OLTP structure. And then there are like analytical databases versus like transactional databases. And there I'm talking about like the hardware more, meaning like Snowflake versus Postgres, right? Sorry, I should put it the other way. Postgres versus Snowflake, because Postgres is our I reversed it. Snowflake is our analytical database. Postgres is our transactional database. So this OLAP versus OLTP structure, right? We didn't learn about any new databases yet, but we learned about different ways of structuring our tables, right? OLTP is what we had been working with all throughout the course until, last week. OLAP is kind of this new way, which I would not say is better, but is just sometimes used in analytical databases, right? And we kind of have these reasons as to why, right? We have, fewer tables, fewer joins, right? Simpler structure for non-technical people, things like that. So we're kind of collapsing like this rigid like formula that I think, occurs more when you have normalized data, right? Normalized data has like very, like, this is violation, like very fixed rules. Yeah, so I'd say OLTP structure, that to me, like, that's the more strict structure that you can think about. It's what we've been learning. Cool. Other questions? Doing this like data model, I'd say when you do data modeling, still do it mainly for like OLTP, meaning normalized, and then you can move to, okay, how would this look if you do the star schema. Remember, like, if you're going to use like this OLAP star schema approach, the first thing I do is identify the fact table, and then we have the dimensions that point around it, right? Who, what, where, when. Okay. Cool. All right, let's move on to this. So we're going to move into Snowflake. Before we do, right, we should just like give an overview of the fundamentals of like how a computer works, because here, the way that Snowflake works is different than the way Postgres works. The way analytical databases in general work are different, and it's really like the hardware underneath That's why, right? That's a big part of the reason why people choose. I mean, that is the differentiator of choosing something like Snowflake as opposed to just keep staying with Postgres. So just to give some background, okay, you can think of a computer as really like consisting of these three components, right? The disk, CPU, memory, right? So by disk, we mean like the hard drive. You can think of essentially like an external hard drive. Just to think of this as a separate resource that plugs into the computer, right? So, and we know what this is for. This is for long-term storage. This holds our files, right? Storing files, okay? Right, when we turn off the computer, this stuff is not disappearing. It's saved on disk. It's actually written to the disk, okay? The CPU, this is for running operations, right? Central processing unit, running operations. So what does that mean? Reading or writing, actually the operation of reading something from disk, right? Or writing something to a disk. Well, that occurs with the CPU, right? This may exist, like we can have this hard drive, but that's and unplug it from our computer. But that doesn't mean we can access data from it without a CPU, okay? Also, like every time you like boot up a program or run Python, right, to actually execute a Python file, like we can have that Python file stored on our disk, but to run it, right, we need the CPU to perform tasks, right, one after the other. And then, okay, so then memory. So memory is used for the same thing as our hard drive, right? It's used to like store and retrieve information, mainly to retrieve data. And why do we have both? Well, memory is faster, okay? It's faster to access data from memory than it is to access it from the disk. And, I showed that, right, that here we read the data the first time, it takes, 24 milliseconds. Here we, do it the second time. This is now from memory, right? And it would take, half the time, 1/3 the amount of time. There you go. So 1/3 the amount of time as when we first read it from disk, okay? So then why don't we always use memory? Well, one, generally your computer has less memory, right, than it's going to have disk, right? Why? Because it's more expensive. That's one reason. The second reason is when you shut off your computer, that memory disappears, right? So we only allocate things that we think we're going to use again, right? This is why like we have this data frame now stored in memory. Once we close the notebook or turn off my computer, we no longer would have that, right? But we have it currently stored in memory because the idea is, okay, once we use it once, maybe we'll use it again, right? But the computer has to decide what to give that kind of that priority to. So why don't we always use memory? It's more expensive than just hard drive, and like it's not permanent. We're not holding on to this when we shut down the computer. So generally, hard drive for long-term storage, memory for short-term access. So it is good to think about like how a database operates in this context, all right? So when you write, when you do create table or insert into, right, rows, so each table in Postgres is stored in a separate file, and then each file consists of this idea of pages, all right? So a page contains generally 1 or 2 rows of data, depending on how much data is in the row, right? You have a page. Again, you might have 1 or 2 rows. And the reason why I say this is because when you do a select all from, on a table, you can think of we're going to a file, and then we're going to read that file, load the relevant contents from that file into memory. And what's the smallest amount you can load into memory? 1 page at a time. So that means even if you do something, right, like select the user's name from users, you're still not just getting, in Postgres, I should say, you're still not just loading the name. That's not happening because it's the smallest amount it can read is 1 page at a time. So you're loading into memory the entire row, and then at least 1 row, okay, at a time. with Postgres, right? So if one page consists of these 2 rows, right, we're loading all of that into memory, and then from there you can scope it down, okay? So our data is stored on the hard drive. We have the CPU read from disk, right? Find, kind of filter out, and save the relevant data into memory. And then from there, it continues to operate on it, right? Scoping down the data, ordering it. Okay. So one thing you can think about, right, is like, this is a little like not inefficient, I guess, in a way, right? Because we're loading more data into memory than we need to, right? We're using users.name. We only need this column, but we're loading the whole row. All right. But that's just how, Postgres works. So this kind of like introduces this idea of there's actually different ways to store our data and to like read our data into memory. All right. So, just to point out, right, the way that Postgres works, it loads entire rows at a time, right? Because that's the way it has to read a page of data, meaning 1 or 2 rows at a time into memory. And this is fine for an OLTP database, right? A database that's meant for transactions. So why is that fine? Well, if you think about like what we use this for, we use it to power a website. And when you go to a website, like back to ESPN.com, and you say, go to like a team, that's probably distracting. We'll go to this. Right, we care about all the information about the team, essentially. Like nothing's going to waste when we load up the team name, that they're in the AL East, their record, right? So, like more kind of concretely would be like an individual. When you click on this person, we care about all of their information. In other words, to translate this to a table, all the columns related to this entity. So one way to think about it is, when we go to a website, we generally care about like just give me the whole row, right? So because of that, it's okay that we read, at least the entire row, because generally the query is going to be something like select star from players, right? Where the player ID is whatever, 100, and it just give me back all the columns related to that player. With an analytical database, however, think about what we care about. We generally don't care about just like one baseball player or one Facebook profile, right? We're trying to perform analytics, which means not just one person isn't going to move the dial for us. What we care about is, okay, can we perform analysis? What I want to load into memory is not everything about a single person, but for for all people or for a lot of people, one single attribute. So for example, here, maybe I care about every person's, birthday, right? Or weight. That way I can figure out the average height or weight of a baseball player, right? So to do something like that, because of these different kinds of queries, we're in an OLAP database, we care about OLAP, we need only a couple of columns of a lot of users as opposed to all attributes of a single user with OLTP, right? We store this differently. So with OLTP, we store our data in a row, right? One row followed by the next row. So you can imagine, I kind of imagine like a movie reel, right? Like if our data is stored in like a movie reel, that it's stored like this, here's one movie, everything about it, and then we have the next movie stored directly after that, and then the next movie. So when I pull out, select all from movies where it's Pulp Fiction in an OLTP, well, that's great because all the data, once I find Pulp Fiction, everything else is right next to it, okay? And I can just load that page into memory, and it's very convenient, right? However, when we move to the analytics database and perform analytical queries, we don't need all the information about Pulp Fiction. Instead, what we need is tell me the year all of our movies were made, right? And maybe we find a count of the movies by year. So this is because that with analytical databases, we store things in columns, all right? So you can think all of this data is next to each other, right, in our spool. And then all of this data is next to each other, etc., right? So now when I load data into memory, I load 1994 followed by 1997 followed by 27, right? And it's easy for me to load, just read this and load all this information into memory. If you think about, just to emphasize how convenient this is, think about if we were to stick with our OLTP structure, and meaning row-based storage, but perform an analytical query. Select, just find the year, or maybe find the average year of all of our movies. Well, you'd have to read, basically, go to Pulp Fiction, read this row at a time, read this row at a time, and then from there, with all this information in memory, just find the relevant year, find the relevant column, right? So you have all this extra data read into memory if we use row-based storage and we're performing essentially an analytical query. So because of that, right, we don't do that, right? Instead, what we do is we store data by column, and then we can just read that one column at a time, okay? Read that into memory. And we don't have to read this extra data into memory as well. So that's the difference, right? This is column-based storage, meaning like the attributes of a column are stored one by one, sequentially. Whereas with row-based storage, an entire row's information is stored sequentially, right? Followed by the next row, followed by the next row. Okay, questions about that, right? Because this comes up, obviously. And people ask about this. All right, great. And I should just point out, like Snowflake stores data this way using column-based storage. Redshift stores data. Basically, all analytical databases will store data using column-based storage, whereas transactional databases will store it using row-based storage. Okay, the next thing is just the architecture of Snowflake. Okay, so this is what you have to imagine is that this is stored in the cloud, right? Like, we're going to get to that. All of these operations, currently we're just doing things on our laptop, but when you move to Snowflake, things are stored in the cloud, and it's distributed computing. So this was, if you like Oracle, like old databases, old analytical databases, or they're still in use. This is how like something like Oracle works, where what you have is, this is called shared everything storage. So what you have is you have our data stored here, right? Maybe in like one central repository. And then with that data, you have CPU and memory, okay? You have like these fixed resources. So you can think of a big computer that has a bunch of hard drives on it, and then also has resources for like the CPU and the memory. Then we have other computers that are able to access this big computer, okay? So when I log in and I want to perform a query on my analytical database, well, I maybe boot up this computer and it accesses the storage layer. To do that, we make a request essentially to the CPU and memory to do a select star statement, and then that goes back to my computer. Now, if 2, 3, 4 people are doing this at the same time, we have what's the word? Basically, we have like a roadblock, essentially, right? Everything's trying to access this one computer's CPU and memory simultaneously, okay? And so that makes, all of a sudden, this makes it challenging, right? The more nodes that we add, that say more users are trying to access this, we're just going to be taxing the same CPU and memory. It's going to make things harder. So, different... Yeah, bottleneck. I think that's a good word. Bottleneck. That's the word I was looking for. So, we have a bottleneck on these resources. So, okay. So what Snowflake does, notice, is there is no CPU and memory with Snowflake. Okay? I mean, they are disattached here, but at the storage layer, it is simply disk, right? It is an external hard drive you can think of, right? A bunch of these things. And then we have computers that all can plug in to this one big external hard drive. Why is this valuable? Because this one computer performing a query has nothing to do with this other computer performing a query. Okay? I mean, in truth, there is like a little bit that you have to worry about, but essentially, not to the extent of our old architecture. So that's the way to think about it. Is they call this isolated compute, meaning here we're all sharing the same resource that we have to rely on. Here, this guy, when I log in and I perform my query, has nothing to do with Data Warehouse 2 logging in and performing its query. So what happens is Data Warehouse 1, has CPU, has memory. We're going to read the data into Data Warehouse's 1 memory and then use the CPU to, complete our operations. Data Warehouse 2 can do essentially the same thing simultaneously, read the data into its memory. And there is no bottleneck at this point. Okay, so this is called, isolated compute. One other great thing about it, so one, I put here concurrency, right? We can kind of perform operations at the same time, not face that bottleneck. The other thing just notice is we can expand the different resources here, one without affecting the other. So what does that mean? So if I have more and more data that I need to store and access, I can just expand the storage layer, keep plugging in more external hard drives. And maybe I still just need, one computer I just have one user, one analyst to access it. Or, as I get more analysts, I can expand this part. Okay? So in other ways, like if you go back to this way, previously, lots of times the more data you have, the analytical database would tend to give you more memory and more CPU. But if you only have one analyst, it's really not dependent on how much data you have. It's dependent on how many different people, how many different operations you're performing simultaneously. So you get to expand this compute layer based on the number of analysts or number of queries, and you get to expand or shrink this storage layer based on the amount of data, which is what you want. All right? They don't have to go together. Whereas you have more data, you also have more compute. Okay? In terms of what costs money, this costs a lot more money than this. Okay? So if you have a ton of data but only one analyst, it's really valuable for you to, just have to worry about one computer booting up as opposed to, crap, we have a bunch of data and now all of a sudden we're using 5 times as much computer resources even though we don't need it. Okay? So this is why, Snowflake, took off like gangbusters. You all might have seen in your externship partners, right? They're pretty price sensitive. That won't go away. It's not because you're interns. That won't go away when you start working for them. They're very price sensitive, and this stuff does not cost that much money at all. Okay, it's this thing, right? The computers that cost a lot of money. All right, so because Snowflake is able to isolate that for you, that's one of the reasons why people tend to prefer it. Questions about this part? We'll go back into this later in the course as well, but it's worth thinking about.
Just to be clear, this storage layer, all 4 of those databases, they contain the same data. They're just copies.
No, I'd say it works differently. So there may be some copy. I don't know actually if Snowflake really does that though. I would say you can think of this as containing different data, but then when you read it, when I perform a query, one thing, I'm a user, I perform a query, it will save some of that into memory and some of that on disk. There probably will be some duplication. Maybe it will duplicate it once just in case something goes down. I'd honestly have to Google that. I forget. But you can really think of this as, all right, I'm expanding. I just have more data that I need to save. Right? To save it 4 times, I don't think most analytical databases would do that 4 times. They would do it twice, right? Okay, so what is this stuff really? When I show this image, what are these things? This is S3. Okay, your storage layer is saved in Amazon S3. What's Amazon S3? It is basically like Dropbox. Okay, it is Dropbox for like programmers, meaning like you can hook it up, you can like read the data from an API, right? But you're storing files there. And you can see what I did is I showed you, when I say files, I literally mean like I can't show you, but these are just CSV files that I just like dragged and dropped into my S3 on Amazon, okay? So this is just a place for you to store files, and that's what they're doing. So why do they do that? This, like I said, this is the cheapest part, is there's no brain here, there's no really computer here, it's just a location that you store files, and that's your storage layer. And literally, you'll see this when you sign up for Snowflake. You specify your cloud provider, so like Google, Amazon, whatever. And if you specify Amazon, it will create, access an Amazon account for you. It has a, S3 access, and it'll store your data into S3 buckets. Okay, so you're just storing it there. There's no computer associated with it. When you want to access the data, what does it do? It boots up a computer for you. And again, it boots up an Amazon computer, which by that we mean like by that it's called an EC2. All right, that's just the name. I don't know why, I forget. I think Elastic Compute 2. Sorry, that's super small. But these things are literally just Amazon computers. We will get to AWS pretty soon, so you will understand this more, but you can think of this, all of our data for long term is stored in S3, and then we have an EC2 computer that accesses our Dropbox, essentially. Here's another EC2, okay, and here's another one. So again, like this is how we can achieve isolated compute, just have literally a separate computer that reads from our S3. Okay, so that's what you can think of when you do that. And here you can see here, this is what it looks like if you boot up an Amazon computer. Like, I just booted up 3 of them, I guess. And that's what you can do. This is called a data warehouse. An EC2 machine in the Snowflake context they call it a data warehouse, which is, to me, a confusing term, because a data warehouse literally is a computer. It is not like a place to store stuff, really. It's a place to perform operations. Okay. Yeah, so you can, I don't know what the point of this was. You can see that we're performing this one data warehouse. Oh, I think my point is a data warehouse can consist of it's really like EC2 resource. So it could consist of I guess multiple computers. You can actually hook up multiple EC2s if you need those resources. You can have 2 of them on this data warehouse and 3 of them over here. It's really you just have to start thinking this as how many resources do you need, meaning how much memory do you need? So if that memory is spread across 2 different computers, or how much CPU you need is spread across 2 different computers, that's fine. Right, we can just ask Amazon to give us access to more memory, more CPU. Okay. So this one has this amount of resources, this one has this amount of resources, and they can access S3 simultaneously. All right. Okay, that was fun. All right, I will let you all, continue reading through this. So it's these less. Nope. Working with Snowflake. Oh, did we not give you access to it? Was this not available? You all did not see this? I guess you didn't. All right, so it's this stuff, not OLAP querying. Understanding hardware, why analytical databases, column-based storage. Is this the right thing? Yeah, column-based storage. So this material, and then working with Snowflake. So signing up for it. I'll let you all move on to this as well. So here we talk about, table. Here you'll actually interact with it. And then, yeah, you can move on. Yeah, we'll just do this for now. And then we'll move on to this, Snowflake queries and commands. So take some time, read through this, and then I'll deploy this material. In terms of what you'll actually be doing with Snowflake, once you navigate it, it's just SQL. It's still just SQL. It's under the hood how it operates differently. Okay, and then there's a little bit of different things, but the SQL is essentially the same. All right, questions before I put you into breakout rooms? No? All right, cool. Purpose of it is to take data from like one database or one external source. It could be like, HubSpot, which is something that like tracks your contacts. Like if people like email me out of the blue, or like a potential student emails me, like that would be like HubSpot. Or maybe like Mixpanel is like where I can track visitors to my website. Now with like to perform analytics on this, we want to connect. We want to take this data from these various sources, whether or not it's like a SaaS tool like HubSpot or Mixpanel, or if it's simply another database like Postgres. We want to move it into move it into our analytics database. All right, so let's see. So here we go. So the first thing you can see is like this destination schema prefix. This is for the analytics database. All right, so it's going to, in the analytics database, it's going to move all the data, all my Postgres data, under this like namespace, right under this folder called Postgres RDS. Because we're going to have a bunch of different sources, we don't want to like mix it up. So then we have the host. For the host, I'm going to need this, I believe. Right? The port, so this is my Amazon RDS. The port is 5432. The user is Postgres. The password is Jigsaw Labs. The database is Northwinds Updated, I believe. Let's just make sure. Jigsaw Labs. And then display tables, and there they are. Beautiful. So it should be Northwinds Updated. Let's just copy this. Okay, connect directly. Fivetran will connect directly to your database. You may have to create a security rule. This is the simplest method. Let's do that one. Fivetran will connect to a server. This method is necessary. So our database is public, so we're probably fine, Update method. I think I normally just do logical this replicates changes from right ahead while using the combination of a logical slot. So this is basically as Postgres, my OOTP gets new data. How do we like add new data to my analytics database? I don't think I need any of this. I think we're good. Let's see what it says. Connect your RDS. You need Postgres, an RDS account. We have that. Access my database server. Access to the host. Choose a connection method. So that's this thing. Connect directly. Okay, connect directly connects directly to my database. This is simplest. So that's why we want to do that. We don't need any. Now we move to the next thing. Choose incremental sync method, right? So to keep your data up to date after the initial sync, we use one of the following methods. Okay, and then it gives these methods. The first three records keep a record of recent data changes, which allows Fivetran to only update the data that has changed since my last sync, right? Not do everything. Fivetran teleport sync, I guess, takes snapshots. So this is different ways of figuring out how to update this and how to determine what needs to be updated. We recommend using logical replication as your incremental. So that's this one. Because it's faster than Xmin and allows Fivetran to detect deleted rows for tables with primary keys. So that's what we're doing. Just use the recommended thing. Okay. Please whitelist the following Fivetran IPs in your firewall. Okay. So I don't believe I have to do this. What they're talking about is, you know how I just got hacked with my RDS instance? One way to prevent that is to say what computers are allowed to access my RDS instance, my database. So that's what this is about. This is saying, hey, you may be preventing almost everyone, right, from accessing your RDS instance, but make sure you allow Fivetran. And this is these are the addresses of our computers that are going to try to access your RDS. In my case, I'm still making my database publicly accessible to like any computer, so I don't believe I have to do this. So let's just do save and test. Oh, I messed up, didn't I? Because my cloud service provider, this is actually I think this will be fine. So I thought that I messed up. If you looked under cloud service provider, it said GCP, but I'm using AWS. So I thought that was bad news. But I think that's okay because that is the cloud service provider. That's how Fivetran is going to power it accessing my database. All right, so it's going to use GCP to access my AWS database, and we get an error. Okay. Please confirm with your database, with your DBA, database administrator, which certificate in the chain should be trusted. Select the trust certificate below. I guess this one.
I selected the lowest one because it actually has the host link there, and it worked for me.
Great. Let's try that. So this one has this thing here. That sounds cool. And I was going to try again. Okay, setup test failed with Java language illegal argument. Must apply publication name for while with PG output plugin. So that's talking about this. I guess it says I need a publication name. I wonder
I
if
just used X-Men and that doesn't require any additional parameters.
Wait, say that. What did you do?
If you use X-Men instead of the wall, like that doesn't require additional parameters.
So you switch to this option, and now let's try this again. Okay, that's excellent. All right, let's keep going. I think, so now we can click continue. So now we've connected like to my source or the connector, and we need to now next set up the destination. So we're going to write Snowflake. So let's do this. All right, so what do I need? So your account.snowflakecomputing.com. So this is the first thing. Yes, Sonia?
Can you kind of went through the setup fields really quickly? It's Postgres RDS because it's not unable to validate setup. So I'm not being able to continue following along with you with
Sure.
this.
Yeah.
Host database, all of that up till Amazon AWS.com, port 5432. And then user Postgres and password Jigsaw Labs, database Northwinds updated. Is that all correct?
Yeah, that's fine.
Okay.
So
Okay. I don't know why it wouldn't be working. Did everybody else?
I think they're probably just watching for right now. I will post this video though afterwards.
Okay.
So follow the setup on the right to connect your data. So now we need to work on Snowflake. So let's go to there. Okay, so this is my Snowflake instance. The first thing about this is this URL. I'm not quite sure that this works, okay? So we need to go to the old view to do that, which is under this classic console. And once I do that, notice we have a different URL. So let's use that. And this is the whole thing. I don't know if I need the whole thing. Let's see. So go here, youraccount.snowflakecomputing.com. So here it is. So I guess it's all of this. Does this look like right to people?
It's repeated twice, so other than that. Yeah.
There we go. Thank you. So this looks better. So this is where it's basically hosted, I guess, in AWS, I think. Okay, the port 5443. Okay, so this is what we need Let me just minimize this for a second. So to connect Snowflake to Fivetran, you need the following: a Snowflake account with the appropriate permissions to create a user and a warehouse for Fivetran. Okay. A Fivetran role with the create destinations or manage destinations permissions. Okay. I think this is okay for now. So we have this, we have the 443. Our user, I guess we're gonna need to create this role. Yeah, this is kind of what they want. So basically we're about to like perform a bunch of insert into statements on Snowflake. So someone has to have permission to do that. So that's gonna be Fivetran user. And the database that we're gonna send this data to is Fivetran. And then for authentication, we want a password. And I guess this is for me to log in, which makes me think that I should log in with my username, which is Jeff Katsy, I believe. Right? That's this guy. And then let me put in my password, if I can. And the role. If not specified, it will use the user's default role. I think I'm okay with that too. Data processing location, the cloud service provider used for running Fivetran services. Okay, then it says, please whitelist the following Fivetran IPs in your firewall. So to do this, we're gonna do copy all. So again, this is like, I need to tell Snowflake, basically tell Snowflake, hey, be prepared or allow Fivetran to use its computers that are located here to access Snowflake. So now go back to Snowflake, let's close this. And let me go here. So when you get into Snowflake, you can see that I'm an account admin. You can go to admin and then security and then network policy. And now let's put in these things. And I believe what I need to do is put this all essentially not on different lines, or not like as it was pasted in, but just do comma separated. And let's give it a name, call it Fivetran. And now I can create network policy. And you see this here, the 6 allowed IP addresses. So now let's go back. We need to continue to go through these setup instructions. So you can choose.
Hey, Jeff.
Yeah.
One thing, you have to activate the security policy as well.
Okay. How do I do? Oh, activate policy right here. Thank you. Okay. Fivetran because is not in the allowed list. Is that? I don't understand. That's my IP
Yeah,
address?
it's your personal one, and you have to add that
I
to
see.
either that policy or a different one.
So maybe we'll do. So I guess we can do that here. So I add in mine, save changes, and then maybe I have to do this. It says inactive, so let's try this again. Activating. Okay. That's exciting. So now what's next? All right, let's go back here. You can choose to create an exclusive warehouse using an for Fivetran to use or an existing warehouse. So again, warehouse is the CPU, or this is the compute, like the EC2 computer. So now the next, sorry, I will read through this. So basically we can use one we already have, or we can create a new one. You can use a shared warehouse to reduce your warehouse running. I think that's fine. We will probably create an exclusive warehouse for Fivetran. Now it says copy the following into a new worksheet. Let's try this, right? And I think it should be a good start. So we'll go to a worksheet. Let's create a new one. I'll call this Fivetran. Setup. And now let's paste this in here. Okay, so this is basically, let's think about what this is doing. So we are setting the role. We're like I don't know if this actually creates a new user. We'll find out. But it, here you can see the password. here's the warehouse, right, that we'll be using, and here's the database. Okay. And this, I believe, this information, this may have to line up to this. Is that right? I don't know.
Yeah. So, I mean, if you're just going to use your default person, you don't have to go through the step of at least creating the user.
Yeah, let's do this, I think. So basically the only thing we could change if we want to is the password, you know? Alright, so let's do that. And then that means that maybe we can replace this. Does that sound right? And the user should be, let's just try this. We'll make the user this user, Fivetran user. Is that right? I guess so. And then it will use the user's default role. Okay. So if you want to create a new warehouse, don't make any changes to the Fivetran warehouse value in the script. If you want Fivetran, so that's what we're doing. We're going to use this Fivetran warehouse in the script. If you want Fivetran to use a shared warehouse, okay, change it. Replace the default value, Fivetran role, Fivetran database, Fivetran user, and password 123 values with values that conform to your specific naming conventions for the resources. I see. So, okay, so we are kind of doing that. We have this Fivetran user, I'll just call it like Fivetran user jigsaw. And then I think otherwise this is fine. And let's just make sure this lines up. So notice I'm copying and pasting everything because things can always go wrong. Okay, run the script. Let's try that. So to run the script, I'll highlight everything and I'll press play. Let's see. And it's going through all the steps, right? 15. That was fun. Okay. What's next? Okay, configure the Snowflake network policy. How do I do that? Okay, so if you have defined a Snowflake network policy, update it to add it. So this is what we've already done, I believe. For example, if you are in the US region, so it seems like you can run this command like in the worksheet, or we could do what we did, you know, go through that private, the security kind of panel. All right, this is, I think we're almost done. Everything else looks optional. So let's try it. Okay, so that's nice. It validated the passphrase, right? That's a shame. Okay, so it database connection, object does not exist or operation cannot be formed. That makes me feel like it's the database, which this might be off. Database is Fivetran. So because it says object makes me think it's a database. So let's look again at my script. The database name was Fivetran database. So let's go here and change that. And then let's try this again.
So
yeah.
actually, that script, as far as I see, like setting the variable. Can we go back to it? Is it actually creating it? Yeah. Can we scroll down? And then scroll down once more.
Create database.
Oh, there we go.
So it will create that database called Fivetran database. So that's a great point. So what's happening here is these are just assigning variables, and then you can see that here it's like executing, you know, actually creating this stuff. So here, create the role if it does not exist, and it's accessing the variable with a $sign. So this is kind of its way of interpolating. Let's see how we're doing. Oh, nice. Even though it broke, I know from experience that sometimes this is good. So let's go to the dashboard. Look at this. Wait, so here's the connector. Let's look at the destinations. Look at this, Fivetran. Okay, beautiful. And now we can go to connect initial sync, complete initial sync, which, how do I get there?
If you go to connectors and then click on the Postgres one, one.
Review connector
Yeah.
here, great. Okay, so this is an interesting panel. We can, in the logs, you can see that it, like this is all the actions that it will take once it has it. This is going to be the schema that we'll eventually see, but let's see this. Okay, review connector schema. So essentially you can determine like which tables you want to load into, right? This is my RDS database. We can determine which tables we want to load into my Snowflake database. So if you want all 22, you just select this. If you want to uncheck some, that's fine too. We'll do all, I guess, and now I'll do save and continue. Okay. How would you like to handle changes? This setting allows you to choose which new source data we will allow all. So basically, if I create new tables, what do you want to do, right? Do you want me to sync them, or do you want to like not sync them by default? And we'll say allow all. Right, if you create new tables in your RDS, in your Postgres instance. Okay, so now my data is ready to sync. And now we can do start initial sync. If we do that, I'll basically be out of trial accounts, but my data will load into Snowflake. All right, I'm gonna do it. I immediately regret it. Okay, your connector is syncing data. We'll notify you. So now let's go to the logs. You can see, okay, blah, blah. Go to the logs. Force update connector. What time is it? 5:02. So we should, eventually this stuff will come here. What would be also be interesting is if we look at the databases. If I refresh this, maybe. Fivetran database. Look at this. Look how nice. And now we go to public tables. No tables. Not as nice. Eventually, there should be a schema that has my. Remember we called it like RDS or something like that. I guess it hasn't yet created the tables, but we should see some, like a schema and tables in my Fivetran database related to that RDS data. I think that's it. So try to do this. Like I said, I will post this video, and then I'll try to help you all. Like Fivetran, it's a tool. It's not the when you work for a company, right? They're gonna have like their website that loads data into a database. All right. So whenever you like put a tweet into Twitter or whatever, that is going to get loaded into their OLTP, right? Or transactional database. And this is Postgres, right? So what we want to do, right, is we want to load that data into our analytics database. And that's Snowflake. All right, and the way that we do that is with Fivetran. So Fivetran is pulling data from Postgres and then moving it over to Snowflake. Now this data, I think I paused my loading, but you could see it. Like if you go to Snowflake, ideally, if this thing worked, your data, you're exactly the same schema, right? Our like normalized data, meaning not in the star schema, but like in like all those little tables, right? Right? This is starting to look like the star schema. I apologize. But something like this, right? Our OLTP structure is now copied into Snowflake, which means we still have some work to do, right? Because we want to transform this into the star schema. So how do you do that? So what we will need to do is, one, you can basically write SQL queries, all right, where you can do something like create table, let's say like Mart, like customers Mart, as select star from customers source. Okay, so you can basically select from this table, and then maybe just select the columns that you want, or perform some modifications in your select statement, and that will, and you can write a statement that both creates the table and inserts the data. All right, and you can kind of from here write a query that then creates a new table for you. We're not going to do this right now. Like, we're going to do this towards the end of the course. But the point is like, while the data is still in Snowflake, right? We've loaded the data into Snowflake. Now, like in a new schema or a new like folder, we'll eventually select this data, change it so that we get to a Mart table, right? To like this structure of our tables. And the way that we generally do that, the way that we start from the source table and then end up with the Mart table, that's with DBT, okay? All DBT does, it has a lot of purposes, but the main thing to know for now is DBT connects directly to the Snowflake instance, all right? It's just like a way that, it's like a central repository for you to write your SQL queries. It does some other things as well, but it's like a centralized code base for you to write your SQL queries. So this way, when you do all that work of like all these queries, you have this like in GitHub, you have it in an organized manner, things like that. So the point is, this pattern overall is called ELT, which stands for, as you probably may have guessed. Can I exit this? Which stands for, no, that doesn't work. Well, it stands for extract, load, and then transform. So why is that? Well, you first extract, let me try this one more time. All right, so you first extract the data from your OLTP. This is what Fivetran is doing. And then it's loading it into Snowflake. So Fivetran is doing the EL steps for you, right? It's loading the data directly into the database. Then after the data is copied into the database with the same kind of format, then you transform it. And this is the DBT, all right? So Fivetran is taking care of the EL for you. DBT is taking care of the transforming of the data from here to here. This is what like an analytics engineer gets paid for. All right, is writing the SQL statements to go from here to here. All right, now this, like if some of you might have seen it, there's a lot of work involved in it, and a lot of, like, I'm simplifying it obviously, but like an analytics engineer will essentially set this up and then use DBT to write the queries that then transforms the data from these, we call these our source tables, SOURCE, essentially are in our OLTP format, to our MART tables, MART. So that eventually then, an analytics, not analytics, like say the marketing team or the maybe even like the business development team or the operations team, they can all just query these tables, right? These simplified tables. Or you could like hook this up to a dashboard or whatever. So to go from here to here, right, we use DBT to write queries, that transforms our data to go from OLTP to like this OLAP format. Now, like, right, I have not talked about DBT. We don't really need to talk about it till for a little while, but this is essentially what it does. It helps you. It's the tool we use where we write the SQL queries that performs the transformations. How does that sound? Yeah, Serge.
So so after the tables are cleaned and organized, where are they stored? Are they stored in Snowflake, or DBT has a like a hard drive, like a storage?
There's DBT is just interacting with Snowflake. It's so they start off in Snowflake, they end in Snowflake.
I see.
Yeah, DBT is like will connect to Snowflake to like ask Snowflake to write the operation. It will essentially like connect to Snowflake and perform the commands. All right, like you it just sits on top. It's kind of like you could have written all this work directly in Snowflake if you wanted to, but then it's hard to share these worksheets and all that. So yeah, so again, like what's nice about this with this ELT pattern is once you load the data into Snowflake, like anyone can access, you're just writing SQL at this point to transform the data, and anyone can access the data in Snowflake, right? Like you can give people access to just like the source tables if you want to, and they can go to town. But normally we want to clean up the data a bit by transforming them into the MART tables. All right, I think there is maybe like, let me see if I can find a diagram. Maybe not. Yeah. Let me see. No, there's no good way. Let me just show you this real fast. So this is DBT, just so we don't have to just like talk around it. It's like it's an interface. This is all exists kind of. I don't know why I can't scroll. Okay, so this all exists, in the cloud. Basically, it's another tool that we'll sign up for. But this with source, this is a CTE. We'll talk, but you can see what we're doing. Select all from. This is our Fivetran, right? We loaded data into our Fivetran database, Postgres customers, right? So we're just selecting data from our Postgres, from that Northwinds public customers table. And then I'm coercing the table, right, essentially, to like kind of split apart my first name. Remember the split part, contact name, split on the space, 1. So this is my first name. This is the last index. This is my last name, right? And now I've kind of cleaning up the data for my end user, and it's ultimately going to create a new table out of this called Stage RDS Customers. And that's like building towards this OLAP, right? So we kind of start with this messy data, and now we're using DBT to produce cleaner data until ultimately like someone in like marketing or whoever is happy to query this data because it's all clean and organized. Okay. So this is, again, like kind of what we'll do, the way that this works is once the data is in Snowflake, we'll use DBT to query Snowflake, which, we start with our source tables, and we'll need DBT to use to clean up our data along the way until ultimately we get to our MART tables. Okay? So that's the task. Cool. So, if you don't totally follow that, honestly, it's okay. Believe me, when you get to it, it's not going to be any harder than anything we've done so far. In fact, one of the reasons why we're delaying on it is just because it's not like a core, like it's a tool, and in the past, people have been able to move through it fairly quickly. So we just want to leave it to the end of the course when it's close to like some of the take-home projects, and you might get something like this in a take-home project. And also you can move through it and then move on to other material like on your own or like as part of post work. All right, but it won't be anything conceptually, I don't believe, too difficult. All right, I've talked enough. I'll put you